Alright guys, welcome back to Underground Science, and in this video we're going to be talking about hydrohalogenation again, but we're just going to go over, this is going to be a short video because we're just going to go over an example of Antimarkovnikov addition relating to hydrohalogenation, but the next video we're going to actually go over the mechanism, the full mechanism of Antimarkovnikov addition for hydrohalogenation. Alright, so let's go ahead and get started. So let's do a quick review example. For this example, the mechanism, we'll go over the mechanism, but it'll be pretty quick since we should already know what the mechanism looks like because we've been doing that for the past few videos. So let's go and go over the mechanism. The nucleophile attacks the hydrogen, this bond breaks, right? So then we have this molecule right here with a carbocation here and a chloride anion here. Then the chloride anion will attack the electrophile and we'll end up with the product, which will look something like this. Alright, and that's the final product. Now let's go over Antimarkovnikov addition in terms of hydrohalogenation. So again, now we don't have to do the mechanism since we already know that the bromine will be attached to the more substituted carbon, right? Because that's Markovnikov. And the more substituted carbon between these two carbons is this one right here, because this is secondary, this is primary, right? Assuming that the double bond wasn't there. So if we drew the product out, it would be like this, with the hydrogen attaching over there. And so what I mean is the hydrogen attaches to the lower substituted carbon, which is primary. The bromine attaches to the higher substituted carbon, which is secondary. That's called Markovnikov addition. Now, the second you see, okay, so first when you see the top, right, reagent, that's hydrobromic acid, so you know it's hydrohalogenation. But the second you see a peroxide group, right, remember we went over this in our functional groups video? If you draw this out, that's a peroxide functional group, right? Especially this part, the O bound to O makes it a peroxide, and there's a real life example that you've probably heard of, which is hydrogen peroxide. So as soon as you see a hydrohalogen combined with a peroxide, right then it's hydrohalogenation, but it's anti-Markovnikov. Anti-Markovnikov is when you add the halogen not on the most substituted carbon, but on the least substituted carbon. So the product for this would actually look like that. Okay, so you see the difference. So this right here, the top is Markovnikov, and the bottom is anti-Markovnikov. And the difference is pretty clear, right? The halogen on the Markovnikov addition adds to the most substituted carbon. And when we're talking about most substituted carbon, I'm only talking about the carbons involved in the double bond. Okay, so this one's a secondary carbon, this one's a primary carbon. If we go to this one, right, this is the secondary carbon, this is the primary carbon. In Markovnikov addition, the halogen adds to the more substituted carbon. In anti-Markovnikov addition, the halogen adds to the least substituted carbon. All right, and in the next video, so this was just an intro video to Antimarkovnikov addition. The next video, we're actually going to go over the mechanism of how this happens. All right, so I hope to see you guys there.